Hi there, future teacher, and welcome to another Praxis 5005 test prep lesson. This is video number 2 in our 3-part series covering all of the Praxis topics about physical science that you'll need to know for your upcoming exam. Now, we will begin this lesson by discussing forces of motion, and then we'll talk about Isaac Newton's laws of motion, and we'll end this lesson up with discussing the different types of energy. You can think potential and kinetic. Now, this video is perfect for audio and visual learners, and if you also want access to all of our videos, as well as the accompanying study guide and our full-length timed practice tests, I've left a link in the description below, so go ahead, click that, make passing simple. Without further ado, let's begin this lesson. Now, let's get started on our new section all about forces and motion. Key topics in this section include types of motion, Newton's laws of motion, and forces and equilibrium. Now let's begin with motion, which is a change in an object's position over time. Common descriptors include speed, velocity, and acceleration. The first type of motion is a uniform motion where it has constant velocity, meaning there is no change in speed or direction. Then, accelerated motion is when an object speeds up, slows down, or changes direction. It's not moving the same way all the time. Lastly, we have projectile motion, which is motion under constant acceleration due to gravity, like throwing a ball. Let's now shift focus to Newton's laws of motion, starting with Newton's first law, or the law of inertia, which indicates that if the net force is equal to 0, an object's velocity remains constant, meaning objects at rest stay at rest, and objects in motion stay in motion unless acted upon by an unbalanced force. Newton's second law says more force makes more acceleration, but more mass makes less acceleration. Newton's third law says that for every action, there is an equal and opposite reaction. Now, let's go ahead and talk about force, or the push or pull of an object. Recall that forces can cause changes in motion, like accelerations, or they can maintain equilibrium if balanced. Now, here are the common types of forces. First up, we have applied force. This is a push or pull made by a person or another object. Then we have gravity, which is the downward force due to Earth's mass. Keep in mind that the equation for gravity is weight equals m times g. Next up is normal force, which is the support force from a surface that stops objects from falling right through it. While friction opposes motion between surfaces in contact. Tension is the pulling force in ropes and cables. Thrust is a push generated in the opposite direction. And last on the list is buoyant force, which is the upward force on an object submerged in a fluid. Now let's take a look at the balance of forces, or what we call equilibrium. When the net force is equal to 0, this means no acceleration. A static equilibrium means the object is at rest and has no net force. On the other hand, a dynamic equilibrium is when an object moves at a constant velocity, meaning without acceleration, due to 0 net force. All right, next up in this section of our guide, we'll discuss the topics that you'll want to be familiar with, all about energy. So let's begin. The key topics include the following. We have forms of energy, energy transfer and the conservation of energy, and simple machines. Starting off, let's recall that energy is defined as the ability to do work or cause change. It cannot be created or destroyed, only transformed from one form to another. Here are the major forms of energy, starting with kinetic energy, also called energy in motion, just like this moving car that you see on your screen right now. Next, there's potential energy, which is stored energy due to an object's position, shape, or structure. There are three types of potential energy, which include, first and foremost, gravitational potential energy, which is the energy that something has because of its height or weight, like water behind a dam. Second up, we have elastic potential energy, which is stored in stretched or compressed objects, just like the compressed spring that you see right now. And finally, we have chemical energy, which is stored in chemical bonds, just like gasoline. Moving on, thermal or heat energy is related to the random motion of molecules. More molecular motion is equal to a higher temperature. Electrical energy is the energy from the flow of charged particles. Now remember, these are electrons through a conductor. And last is light or radiant energy, which is energy carried by electromagnetic waves like the light from our sun. Remember that energy can be transferred between objects or converted from one form to another. For example, a hairdryer changes electrical energy into heat and moving air. The conservation of energy means energy can change form, but the total amount stays the same. An example would be when a rolling ball stops. Its moving energy, called kinetic energy, turns into heat. Remember, that's thermal energy from friction, but no energy actually disappears.